Assalamu alaikum, my dear students. I hope all of you are fine and doing well. The topic that we will discuss today it is the hydrides. Basically, hydrides are the binary compounds of the hydrogen with the metals, or we can also say that binary compounds of hydrogen with other elements. So these other elements can be from any group. It may be from group 1, from group 2, and so on. It may be group 7A. So we can take the different examples of the binary compounds. Here we have the hydrogen bonded with the lithium. So this is lithium hydride as the lithium is having bond with the hydrogen, and this is a simple binary compound of the hydrogen. There are different types of the hydrides that depends upon the nature of bonding between them. What is the nature of bonding or how the bonds have been formed, and then the second thing it depends upon broadly on the type of elements that is bonded, type of elements that forms the bond with the hydrogen elements. On the basis of this they have been classified into different categories. So the classification of hydride is done basically into three forms. The first one we have saline, or it is also called as ionic hydride. The second we have metallic, or it is known as interstitial hydride, or we can also say that it is known as intermediate hydride. And third one we have molecular or the covalent hydride. So the ionic hydrides related to the ions. As it is related to the ions, it's mean when we have another example for the ionic hydrides, the hydrides formed by the group 1 and the group 2A elements are strongly ionic in nature because they are the heavier members of the periodic table, and they can make the bond with the hydrogen and forming a binary compound. So let's have discussion about the ionic and covalent hydrides. The first one we have ionic hydride and covalent hydride. So basically covalent hydrides, the hydrogen atom is covalently bonded to the atoms of the other elements. Mainly in the periodic table, we have group 1, group 2A, 3, and then we have group 5, 6, and 7 elements. These group elements form the ionic hydrides. These ionic hydrides are basically solid in state, and they form the strong bond with the hydrogen. And when we move from left to right in the periodic table, now group 6, 7 elements, they will form the covalent hydrides, and these covalent hydrides are having also strong bonding with the hydrogen. So the compounds that form between hydrogen and the most reactive metals, especially with the alkali and alkyne earth metals, these group have 1 and 2 elements, they form the hydrides. These hydrides are known as basically ionic hydrides. And ionic hydrides are having strong bonds, so that's why they have high melting and boiling points. They have high melting points. On the other hand, when we have a look on the covalent hydrides, they are mostly present in the gas phase, or they may be the liquid, and these liquids are highly volatile in nature. Volatile in nature, they can be easily converted into the simple vapors. So we have a lot of examples of the covalent character. As we moving from left to right, the hydrides of group 1 and 2 they form ionic hydrides. We can have a lot of examples from group 1A and 2A. We have lithium hydride, we may have sodium hydride, potassium hydride, and then from the group 2A we have beryllium hydride, magnesium hydride, and calcium hydride. These hydrides are basically known as the ionic hydrides. On the other hand, from the group 4, 5, and 6, we have different example: methane, we have ammonia, we have water, and we have hydrogen fluoride. These are all known as the covalent hydrides. They are covalent in nature as the non-metals forming the bond with the hydrogen. So that's why they are covalent in nature. As I have already told you, they may be present in the gases or the volatile liquid. On the other hand, they are known conductors. They are known conductors and they are also soluble, or they also get dissolved in organic solvents. All the organic solvents, the solvents that have carbon in them, are known as the organic solvents. And on a whole, their energies depends upon the size and their electronegativity. Electronegativity is the ability of an atom to attract the shared pair of electron towards itself. This is known as the electronegativity. So their all energies depends upon electronegativity and the size of the molecules. So this was a simple overview about ionic and covalent hydrides. After that, we have the intermediate hydrides. Intermediate hydrides, these are the basically hydrides of beryllium and magnesium. These are known as the intermediate hydrides. These type of hydrides have both the properties of ionic and as well as the covalent hydrides. So that's why they are known as the intermediate hydrides. And beryllium, it is present in the form of hydride, beryllium hydride BeH2. Then we have the zinc hydride, we have cadmium hydride. These form the intermediate hydrides and they are having both the properties of ionic and covalent, and they may be have strong bond or they may be have the weak bond. It depends upon their nature of bonding. So this was all about today's lecture. I hope you guys understand, and if you have any queries you may ask me about that. And the next topic that we will discuss, it is the oxides. For that time, you guys have a good day and Allah Hafiz.